Be very brief when I talk about zero order reactions because these reactions are a little bit more rare, and typically you only see these zero order reactions when you've done something like add a catalyst. So as this example shows right here. And that doesn't mean all catalyzed reactions are zero order reactions, but it's a common occurrence. And we will be talking about catalysts soon. So if you're like, I've heard that word, but I don't know what a catalyst is, don't worry, we're going to be talking about it. So in a zero order reaction, what's kind of peculiar about this is you notice here that I'm showing you this as like an A goes to products. And then you notice like with one single A, right? And then you notice here in our generic reaction, we've got two N2Os, but with a catalyst, this proceeds as a zero order. So what does that mean? Well, in a zero order reaction, the rate is independent of concentration. So rate is independent of concentration. So in other words, if we look at this rate law, rate equals negative delta A over delta T, which equals K times A raised to the zero power for zero order. We know anything raised to the zero power is just one. So the rate is only dependent upon the rate constant. So that means in a zero order reaction, if we were to change the concentration of our reactants and that doesn't affect the rate at all, then we know it's a zero order reaction. And that's why some of these are kind of a little bit rare, because most of the time in chemistry, when you change the concentration, it does indeed change the speed or the rate at which the chemistry proceeds, okay? But not in the case of a zero order. So if we were to do the integrated rate law, we would find the zero order reaction is a very straightforward integrated rate law. It's just y equals negative mx plus b. So this is just concentration. So we don't do any manipulation like we did with first order and second order. If we were to plot concentration versus time and we see this steady linear slope, then we know it's zero order, and the slope, of course, gives us the rate constant as all of the other examples. But again, we've not made any manipulation to the y-axis. We're not taking the natural log. We're not taking 1 over. Just straight concentration versus time gives us a linear decay. Okay? So our half-life equation, we can write that down. So that's going to be the initial concentration of A over 2 times the rate constant. So that'll give us the appropriate half-life. And so also when you think about it, units for zero order rate constant must be the same as rate. Because here we can see in this rate law, it's just saying rate equals K. So that means the rate constant units are molarity per second, okay? And that's pretty much all I'm going to say about zero order reactions. And I want to shift now to the summary document here. This is everything I want you to know about these reactions we've talked about, zero, first, second order. So you should be able to call up the rate law for just a simple example. The integrated rate law, those are equations that I'll give you. So let's get a different color here. So everything that I circle in red or square off in red, you will be given that on like a equations sheet, okay? But I'm not necessarily going to tell you which one is zero, first, or second. You've got to recognize that the zero is concentration, the first is natural log of concentration, and the second is 1 over concentration. So you need to know the plot for a straight line. I'm not going to give you that information. I want you to be able to know what the plot for a straight line is. So we can see this, the slope for all of those straight lines are going to be the rate constant. Some of them are negative, second order is positive. All of our rate constants are positive. So the fact that the slope has a negative sign is not as important. What we want is the absolute value of K. So half-life equations, these I will also give you, but you do need to recognize which one is which, okay? And then finally, the units for the rate constant, you need to know that, okay? So let's say will be given these things. But the other information on this chart, I do want you to know, okay? And certainly for the units of the rate constant, you don't have to memorize those if you're good at working through the dimensional analysis process, okay? All right, folks, so that's our summary on 0 first, second order. So in the next set of videos, I'm gonna do some sample calculations on what we do with all this information, okay?